Let's look at the inverse sine function. So we start here with a graph of y is equal to sine of x. So the domain of this function is the entire number line. The range we can see on the graph is between -1 and 1. So y only ever takes values between -1 and 1. So we say that the range is the set of all values y such that, that's what those two dots mean, -1 is less than or equal to y is less than or equal to 1. So the range of that function is all the values y such that y is between -1 and 1. If we pick a y value, let's just call it c, you can see that for that y value, c here is about 2.5 or something, but you can see that for this value c, if we look across, there's actually many values of x for which f of x is equal to c. So you have one here, one here, one here, one here, 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 here. Actually as many as you like, because this function goes on forever. So if we're given a y value c, there are infinitely many x values for which sine of x is equal to c. Therefore, there is no inverse. So how do we get an inverse sine function, given that the sine function doesn't really have an inverse? What we do is we restrict the domain of the sine function so that the range from -1 to 1 gets covered just once. The convention is to choose the domain to be between -π/2 and π/2. So we throw away everything outside of that and we restrict ourselves to that domain. And that gives us this curve. So here's x, y, and so that is with the domain x between -π/2 and π/2, we hit every y value exactly once. So this new function with the restricted domain does in fact have an inverse, and it's the inverse of this function that we define to be the inverse sine function. If I told you that the sine of some angle x was 0.5, there's lots of values of x that would satisfy that requirement, but if you use the inverse sine function, that will always return the value that's between -π/2 and π/2. So this is the graph of our domain limited sine function. The inverse of this would be the function that you get by swapping the x and y axes. So there's what it looks like if you do that, but of course the actual inverse function, if I write it as y equals f of x, so x will be on the horizontal axis and y on the vertical. So that means x here and y here. So that is y is equal to inverse sine of x. The domain of inverse sine is between -1 and 1, and the range is between -π/2 and π/2. And that is the inverse sine function. Try to see now if you can work out an appropriate domain and range for an inverse cosine function and an inverse tan function.